basically during the pandemic, it was like we kind of, well, I mean, in the initial mad scramble, we weren't really given much direction as to what to do at all. I had like a 2-week lead on the situation. Oh shoot, they're probably going to lock us all down, because I was paying attention to traditional media and non-traditional media, and the non-traditional media was leading the traditional media in terms of, oh wait, the pandemic's it's gonna be bad. So yeah, I started my planning for it a little bit ahead of time, and I managed a pretty smooth transition, but we weren't really given very much direction in the initial phases. It was like a month later, they were like, oh yeah, maybe you can use video conferencing, or maybe it took a couple of weeks, but it wasn't like right on it. But I was like, well, video conferencing always seemed like a bad solution for it to me, because fundamentally what the purpose of that is it's many to many, right? Whereas video streaming is one to many, which basically that was my preferred model, and I used the YouTube chat to that was how students did questions. I did polls and all kinds of stuff, and people generally were there was a really good reception to it at the time, because everybody else was doing awful things. Yeah, Zoom apocalypse, right?
Mm-hmm.
Well, it's if you calculate it up, over the course of a semester, if you're taking one course to me, you have to listen to me talk for 50 hours. You might as well do it in decent audio quality, right? So, but yeah, that's kind of how I got into it. And the channel post-COVID was just kind of this was initially a transition stage, because although classes were back, not everybody was wanting to come back to class. And I was like, well, I'll still record, I'll still put it up. You guys, if you don't want to get the bug and be back in a room with all of the people who might be having the bug, then here you can still watch a video. And I just kind of kept doing it. People seem to like it, so I'll keep doing it. That's just how it works. Yes, databases. I'm very distractible today because I didn't get much sleep last night. The toddler is teething.
Oh.
Yeah.
What grade is your other child?
I have 3 children.
Oh, I thought you had 2.
That's okay. It's a common mistake.
Maybe you just don't talk about one of them as much.
Well, I mean, maybe. They're all very cute. It's probably the middle child I don't mention, right?
Yeah.
She's great though. Yeah, so I've got Felix, he's 4 years old. I've got Dee Dee, she's going on 3 next month. And then I've got little Theo, he's a year and a bit. So he's the one who's teething. Everybody else has all their teeth, thankfully.
That's good.
Oh man. Dee Dee was quite the terror when she was teething. Oh man. But it is what it is. So, man, teeth. It's like your mouth would be perfect if it just weren't for the teeth, So, it's kind of like school would be perfect if it weren't for the students, right? Always said facetiously. I love students, right? Anyway, so today we're going to be talking about insertion, deletion, and update operations. So data modification, as it were. So far in the course, we have been almost exclusively talking about select queries. Now, I've been digging into this course a little bit, trying to understand what's expected for the midterm and that sort of thing. And I've been talking to Dave Gilbert, who is also teaching the course and has taught the course for a few years and understands it better than I do. I voiced my observation, the midterm didn't seem to have, like, very much except select queries. And he said, well, yes, that's because when you folks go out into industry, your work related to databases is likely to focus very, very heavily on select queries, right? But you still need to know how to set up a database, you still need to know how to, you need to know these basic operations too. It's just, select is, like, understand that when somebody asks you or employs you to work with a database, select is gonna be like most of your occupation. I mean, very often, in the modern era, like, we don't have, not to the same degree, we don't have people whose job it is to just sit there and punch numbers into a database. A lot of the time, the information the database is collecting is like, it's derived from people filling out web forms, and it's data that's being collected from programs as they're operating. The data sources are not necessarily an operator sitting there at the computer typing in insert queries. But again, you still need to know how to formulate them. Yes?
Because I think these days SQL is mostly used hand in hand with other programming languages than on its own.
Certainly. In fact, basically, once you get into serious web development, you'll be using things called frameworks, right? Frameworks often have subcomponents called ORMs. I can't remember what ORM stands for at the moment. Maybe somebody else knows. These are basically wrappers for database operations and SQL queries. So yeah, absolutely. That being said, when you guys are doing, for example, your PHP work, one of the things you will need to know how to do is to formulate, all of these CRUD operations, because these are the types of things you expose with the web API, right? So, CRUD, create, read, update, destroy. Each of these corresponds to an SQL verb. Insert, select, update, and delete. You can see that update and delete, there we go, same word. Select is read, I'm sure everybody got that by now. Create, in the CRUD sense, is to insert data into a table. So, insert statements may insert one row or many. Do you guys think that needed a whole slide?
No.
Well, I kind of think these slides need an editor.
We definitely are very talented.
Yeah, but another problem for another time. Here is your syntax for insertion queries. Insert into table name. In order to insert data into a table, you need to know what table you're inserting it into. Optionally, remember wherever we see these square braces, this means that this part is optional, right? When we see syntax given. This is optional. A comma-separated, round brace delimited list of attributes, column names. We then have the keyword values and another round brace delimited, comma separated list of values. So what is meant by value here are the actual values you are trying to put into the table. These are the data. This is where you put the data. There's a correspondence here. Value 1 will be given in column 1, value 2, column 2, 3, 3, 4, and 4. Make sense?
Yeah, like values is like the method, and like that the parameters is like what you're passing into the thing.
Well, like this is a method. Yeah.
Yeah.
Sorry, yes. This is you can think of it a bit like a function call. Yeah.
Yeah.
Where this is where you're specifying what the arguments to the function is.
Yeah.
Not a bad way to look at it.
Thank you.
So, does this make sense? Any questions so far?
So basically, if you're using the optional, you don't, like, when you're doing the values, so let's say you specified in column 1, then the values you would only have to type in column, the value at 1, right?
There-
Instead of, like all the others?
You are actually anticipating the next couple of slides where we discuss the optionality of that line. So, first, before we talk about the column being, listing columns at all being optional, note that the list of columns that you provide does not necessarily need to be all of the columns in the table. In a sense, the purpose of this clause is to select which columns in the table you're inserting data into for this record. So in this particular example, we are not doing anything for column 2 or column 4, only for column 1 and 3. You can see that the values which are provided, the length of this matches the length of that, right? The length of this matches the length of that. So this is only possible if null values are permitted or default values are specified for the things you leave out, right? Essentially, what's gone on here is I have chosen not to provide values for columns 2 and 4. If null values are not permitted for column 2 and 4, or if a default value is not specified for these columns, I am committing a syntax error, right? I must provide, if values are required, you must provide them, basically. Does that make sense? Any questions? Okay. So, let's consider the following table schema for a dental services table. We have service ID of type integer, not nullable. So depending on what type of system you have, this property will be named different things. Sometimes it's called required, right? Required? Yes. If it's required, then it can't be null, right? It's the Boolean inverse of nullable. But yes, I think the term nullable is kind of clunky, you know? But we have a description, variable character array, service type, single character, hourly rate, and sales year to date, both money. So, if I were to not provide a service ID, I would be committing a syntax error, right? Because without that, it's not a valid entry. That's another way to think about nullable. If I leave it out, is this still a valid entry? No. Let's consider the sales table schema. Very similar. Again, sales ID is non-nullable. You may be saying something though. We'll get to keys in a moment. So, let's consider the following. Can you guys read that in the back? That's kind of small. Is that okay? All right. An example. insert into dental services, service ID, service description, service type, hourly rate, and year-to-date sales. Values, 600, temporary filling, F, 100, 0. You provide the values, they correspond to each of the columns in the table. Hopefully this is fairly straightforward. Hopefully this is very straightforward, is the motto not only of this class, but this whole course. Yes?
So it says like insert into dental services, right? But what if it was like insert into dental services and like dental like another name? So you have two tables and then values, like which one would, like how would you specify which one you want to fill with
I'm
values?
pretty sure that's a syntax error.
Okay.
I don't think you would be able to perform an insert operation onto multiple tables at the same
No,
time.
yeah, it's just one.
Yeah.
Okay.
Um,
So like if there are more than one tables, then how would you specify like which one you want to like fill with values?
You just say the name of the table that you want to fill with values. If you have two and you want to insert data into both of them, you use two insert statements.
Oh, okay, I see.
Make sense?
Makes sense. Thank you.
Very good. Any other questions? So, in this example, all column names and values have been provided. In this example, not all column names are not provided, so all columns must have a specified value. This is the point that you were bringing up previously. What happens if we leave off the schema, right? If we leave off that set of column names which we are writing to, the requirement is we give all of them in the order that they appear, right? So basically, the thought is, in this example, because literally every column in the table has a value associated, do we really need to know this? Right? We're not providing any information by doing this. The information that we provide with this is, if I'm only writing to a subset of these columns, what subset? Right? If I'm writing to all of them, I can just provide the values. Does that make sense? However, it also means that SQL can't decide what subset of columns you're writing to if you provide less than the total number, right? It's not going to make that assumption for you. Like if you were to leave off this one, right, or these are both money. So if you were to provide one money field on the end of here, well, is it hourly rate or is it sales to date? Right? SQL's not going to make that decision for you. So it's just going to say, you have a syntax error, sir/madam. Make sense? Good. So, that's what we have in this example. All columns have been provided for because the column names have not been provided. It may even be, like, let me level with you for a second. This thing is a pain in the keister to write out. Just a right royal pain. Avoid it if you can. If the only purpose of specifying all those things is to leave out description, right? So you don't have to, provide a description here. You can just as easily provide an explicit null value. Then you don't have to give the whole schema, right? These are logically equivalent operations, right? It's logically equivalent to write 4 of the 5 fields and leave the null out, to providing null as a literal, but this one is significantly less writing. And if there's one thing that we as programmers love, it's not having to write things. So, very good. Any questions?
Good.
So, let's see. I think I'm going to, load up SQLite now, and we'll try one or two of these. If you have a computer in front of you, I just can't be bothered with Microsoft today. Today is not a day for Microsoft. So if you go to SQLite 3, search that, get the SQLite home page, go to downloads, pardon me. What you're looking for are precompiled binaries for Windows. So,
Which one is it again?
it's the one at the bottom, I think.
Okay.
Yeah, you're definitely not an ARM architecture, so yeah, you want x86 architecture. Unless you're like one of the ARM Macs, this might be one of the rare cases where you actually, yeah. If you're, so if you didn't know, the Apple Silicon Macs are like ARM architecture. That's what the architecture is called. So when you're looking for like stuff like this, if it says like x86 versus ARM64, if you're Apple Silicon, it's ARM. If you're just like a normal one, then x86. x86 basically means Intel chipset, or the AMD chipset that's equivalent to an Intel chipset. Anyway, save, open, extract. There we go. You get a number of executables. The one that we want is SQLite 3. Double click, and oh look, it's a cute little command terminal. Yay! So with this guy, you literally just enter SQL commands and it saves it to a database file. .open opens a file. Let's call this class.db. Databases usually have the .db file extension. Usually, if you've been, in enough of my classes, you'll know that they don't actually exist. File extensions don't actually exist. They exist, but they have no substance. So anyway, if you say .tables, I can't go into it right now. It's too controversial. That'll tell you what the tables are, unless your question was about something else.
Oh, I was just gonna ask, did I install the right one? I just installed the second one here from precompiled binaries for Windows.
Try the one at the bottom.
Okay.
Yeah.
Thank you.
So let's create a nice little table right here. All right. Create table. What should we do? Video games?
Sure.
Okay, video games. That will have a integer ID. It will have a in SQLite it's permissible to use text for string. Name, text, genre, and int rating. Come on. Oh. I'm still in Java. I'm in Java land. Text. Text. Int. There we go. Tables. There you go. Video games is a table. Boom. If we take a look at everything in it, select star from video games, semicolon, you have nothing in it. So one of the reasons that I'm like, one of the reasons that I use semicolons quite a bit is like SQLite will not process a transaction unless it has a semicolon. Like that's what it did here. It's like, okay, select star from video games and finish. Okay.
At least it doesn't, it's not like other things where it just like, oh, you gotta write the whole thing again, and then you just won't run it.
Well, you're also in a command line environment, right? So you
Yeah.
can scroll through previous commands by using the arrow keys,
Yeah.
which is extremely convenient. So, insert. Insert into video games. Values. Let's do it with the schema first. ID, name, genre, and rating. Values. Video game one. Someone give me a video game.
Halo.
Halo. Presumably the first one. Genre.
FPS.
FPS. Frames per second. Rating
M.
on a scale from 1 to 10.
Oh.
M?
10.
10.
Okay.
Oh. No such column. Wait, what? Oh. It wants single quotes, I think.
Yeah.
Yeah, I'm still in Java land. There we go. So now if I select, there we go. There you go. We have data in the database.
Yay.
Hooray! So, let's say that I have one and I leave the rating off because it hasn't come out yet. What's a game that hasn't come out yet?
GTA 6.
GTA. Oh, no, wait, whoa. No, if we're gonna do memes, what is it, Half-Life 3?
Oh, yeah.
Portal 3.
Portal 3, there we go. That's more my speed. Portal 3, FPS/joked game. No rating. Now, the way that SQLite shows it will be a bit different, of course, from how it's shown in Microsoft. But the way that it shows null is to just sort of print empty string and just not give you a value there. So that's what null looks like here. Make sense? Very good, very good. So far so good? All right. Let's see. Anything else I need to demonstrate? Here. So. This is one that is a little harder to rep. I'm sure that SQLite does it, but I'm not sure how it works. So this will be like, this is your Microsoft portion. So employee ID is a primary key and an identity, right? Absolutely. This means that this value is calculated from existing records. So you don't have to provide it. So if we consider this as a schema for the employees table, right? Employee ID, name, birthday, and salary. Salary must be greater than or equal to 0. So you can't work for negative salary, but you can work as an unpaid intern. Try not to take an unpaid internship if you can help it, guys. In this insert query, you'll notice, although we have not specified the columns we are writing to, we do not have all of the columns represented. The one missing is the ID. That ID is being generated for us. It does not need to be provided in the statement. Make sense? Cool. Alright, how many people are sleeping? How many people are on their phones?
So identity is only used for primary keys, or can be used for any kind of,
Yeah, so the identity keyword can be applied to one of your fields to basically, this is where you tell it to auto-generate the numbers, right? Like, remember that a primary key doesn't have to be an M-bun, right? You guys remember what M-buns are?
Something but a unique number.
Yeah, meaningless but unique number.
Yeah.
Yeah, so it's the ID can be a sequential sequence of integers, or it can be random cryptographic numbers, right? One is better for systems that are not distributed, the other is better for systems that are distributed, right? Like, you know, tweet IDs in the Twitter would not be sequentially numbered, they would be numbered with cryptographic strings, right? But yeah, that's where that's being set. That's where that property is being assigned.
you just tell the system to auto-generate a random unique number.
Well, in our case, it's not going to be random, it's going to be sequential, but yes,
Okay,
this
that
is,
sequential, okay.
yeah. Cool. So inserting multiple rows. Now, I know what you're thinking. Surely this just means that I'm now providing an array of arrays. But you'd be wrong. You'd use multiple insert statements for that. In fact, what multiple insert is assigning the results of a select query to values in another table. This is somewhat similar to creating a view, except in this case we're not like. This would be a pretty good midterm question actually. What's the difference between doing this and writing a view? Right? Who can tell me what a view is?
So like a pre-made query, basically.
It's a pre-made query, yep. So a view is when you take a select query and you bind it to a name, and then you can use that query as if it were a table, right? But the big difference is it's not stored in memory. The view is calculated every time it's called for. The difference with this, we are taking the same thing, the output of a select query, but we are storing it in a permanent table, right? So this has a couple of effects, right? You can continuously append into a table this way, right? But essentially, it's a similar concept. We're taking the output of a select query and we're binding it to a name. In this case, we just happen to be writing it into actual gosh darned memory as well. Whereas with the view, we do not write it into memory. We do not save the values in an actual physical table. We recalculate the view every time it's called for. Does that make sense? Sort of, a little bit?
And then so the calculation will be done on the server, right?
Yes, yeah.
Rather
Yeah.
than like the client getting the data and then processing it there.
Oh yeah, no, you absolutely do not want any of this passing forward to the client whatsoever. Because that would be a data breach, actually. That's like almost the definition of a data breach, actually. I'm so glad that we're having these conversations so that you guys know security and stuff. Because like, you know, oh man, you guys hear about, did you hear about in Europe what was going on with the airplanes?
Yeah.
What happened?
there's like some big cyber attack that happened in airports, and it shut down. Shut down the self-serve check-in terminals.
Oh.
And so, like, and I think some of the check-in apparatus, but like, apparently things were like back to the way that they were in the 50s, where you had like check-in attendants writing out people's boarding passes by hand with paper and pencil. It's like, here's your boarding pass, you know, just like in the 50s. But yeah, so.
The good old days.
Yeah, the good old days. Well, at least you know, a simpler time with fewer computers. And as we know, computers ruin everything. So obviously the 50s was better because it had fewer computers. But yeah, so yeah, that apparently like a fairly large number of flights were canceled, and like places in Germany like Munich and places in Belgium like Brussels, they were having like, it was a big news story, and it was a cyber attack. So internet security, increasingly important. Yeah. All right. So let's consider the following table. All right. The purpose of this SQL query is mainly to show you the schema. We are creating a table, Dental Services Archive, which has service ID, description, service type, hourly rate, and year or sales to date. You, if you've been paying attention, may notice that these are all 5 of the same column names from previously, right? The previous dental services table that we had all 5 of these columns. No constraints though. So, if we perform a multiple insert into Dental Services Archive, the table we have created for this purpose, we have provided all of these labels, all of the column names. Yes. We then select all of these different values from the dental services table. So I guess the idea here is that the dental services table is like periodically cleared out, reduced in size, so that, you know, probably to speed searching, right? If you have to search the entire history of all transactions that have ever occurred to find something interesting about one that happened in the last week, this is probably an inefficient use of resources. So, take the table contents and once a week dump it into the archive, you know, or dump everything that occurred in, like, you know, between 3 weeks ago and 2 weeks ago into the archive, so that like your sort of active area of the table only covers the last 2 weeks, but you still satisfy your governmental requirements to keep a record of your transactions. So, you guys remember you can do this with select queries, right? This is an unfortunate way to do it because this is basically the same thing as select star, right? This is what select star aliases in the case of this table, right? Make sense? Good. The next slide points this out. Select star, we do significantly less writing, but what flexibility have we lost? We have lost the ability to specify this in any order we choose. We can no longer, you know, add the columns in an order other than the ones they occur in. But of course, if you're doing all of them, why would you want to do that anyway? We can, in fact, remove all of those fields as well, because we're using all of them. So the query simplifies quite nicely down to insert into dental services archives, select star from dental services. Make sense? Good. Consider the following, however. Perhaps not all of the information which is kept in the dental services table is required to be stored in the archive. Maybe you only need to store a subset of it. In that case, you can provide only a subset of those values that you need to put into the table. The rest will be automatically assigned null. So in this case, we would have 3 columns that were all entirely null because they're not being provided by the select query. Does this make sense? Yeah. Good. As you can see, this is a slight modification on the same table, just to illustrate the fact that because, as you may assume, because this is a select query, we can include a where clause and restrict, filter out which entries we are multiply writing into the table. Good? All good? Some of you are trying very, very hard to stay awake. I appreciate the effort. All right. So that's all we have to say on the subject of insert queries. Delete queries are quite a bit less complicated. So when we are deleting rows in their entirety. We select a row and we say, you are relegated to the dustbin of history. You no longer exist. We are deallocating you. So you can delete a whole lot of rows all at once using the where clause. You must be careful when doing this. Basically, the where clause on a delete operation is filtering the table for the rows that will be deleted. What do we get if we don't have a where clause?
You get nowhere.
Just deletes everything.
Ha-ha! Very good. Yes, it deletes everything in this case. If we leave the where clause off, then there is no filter. All rows are selected. If it's a delete operation, all rows will be deleted. Make sense? It is only very rarely that you'll want to delete all of the rows in a database, or in a table in a database.
So
Yes.
then, is the table still existent, just null? Or
Yes.
is the table actually gone?
The table itself still remains, but it contains 0 entries.
What if the entries cannot be null though?
Well, it's
They're not null, they just don't exist. There are no tables, there are no entries there.
yes.
So what are they? If you could pin
They're-
it down to a word.
Nothing.
They're
gone.
I'll show you.
I assume blank.
Yeah.
Let me
I'm
show
looking
you.
for a keyword.
So
Destroyed.
right here, right, I create the video games table. I say, give me my tables, video games. Then I do a basic select query on the video games table. See the output I got?
Yes.
I got no rows of output.
Oh.
So the table contains no rows. The closest analogy would be an empty list or an empty string. Right? It's just an empty table.
Like, say you had say you have a shopping list and then you just write shopping list on the top. What do you have under that?
Nothing.
So if we do a mistake, is there a way to bring it back with the right title?
Depends on your database management system. In SQLite, no. You may or may not be in a position where, like, accidentally deleting everything in a table will cause, like, consequential data loss. So this is, like, it depends on how frequently your database is backed up and in what manner, right? Let's say, let's say you back up the database nightly, right? If you accidentally delete everything in a table, that means you've lost a whole day's worth of whatever you're storing in the database, presumably something important. Transaction records, if you're a retailer, patient records, if you're a doctor's office. You catch my drift. It's a dangerous operation. It's one short of the absolute nuclear operation. Anybody know what the nuclear operation is? Yeah.
Yeah, drop.
OpenAI?
Drop.
Drop table. Yeah. There you go.
Mm.
So the drop command deletes a table. The difference between deleting everything in the table and deleting the table itself is, after delete with no where clause, you have the table, it's just empty. After this, you lose the table itself, which means if you want to restore it, you have to re-enter the schema, right? So yeah.
There was actually one where a guy put like an SQL injection on the front of his car where he got
Ooh!
the speed cameras and then dropped the table for all of the license plates in the database.
That's actually a fire guy.
Did it work?
I think it did. Yeah.
Oh, come on, the police.
I should respect it.
That's lol. Yeah, that's good. Oh man. So if you don't know what this is called an SQL injection attack. We will be talking about SQL injection attacks in the server-side programming course once we start talking about integrating databases and that sort of thing. But essentially the problem here is that this string contains control characters for SQL as a language, which means that gets... There we go. All right, so... Anyway, sorry about that glitch in the matrix. So, where were we? Yes, we were talking about delete statements. So, it doesn't warn you that it's going to do this. It just does it. This is kind of, once again, the how easy is it to shoot yourself in the foot in the programming language problem. So, deleting a single row from the table, if you use the primary key, that's like one of the good uses of it, right? It's like, that is a unique identifier for the particular row in the table that you may be interested in deleting. Use it, right? It's guaranteed to be unique. So the problem though, and this will be a thing that Microsoft is checking. If you delete an entry using this primary key, it will check to see if anything is using that primary key as a foreign key in another table, and it may refuse to do that in an effort to maintain referential integrity. What is referential integrity? It's not the thing that FIFA lacks. Actually, FIFA's probably fine. So, what this means is you don't want broken links, right? When you have a table with a foreign key which refers to keys in another table, if the entry in that table it refers to suddenly disappears, you can end up with a broken link. In the first table, you can end up with a foreign key to something that no longer exists. This is a, as they say, problem, right? You don't want that. It's the same thing as having it's like having an object instantiated in memory in Java and then no longer having a variable that refers to it. These things get garbage collected, right? That kind of problem. So, sometimes this will be the case, sometimes it won't be the case, right? In the example presented, 300 is a value used in another table, even though we're not ever shown that. 600 is not, so this item will be deleted for your pleasure. So, the from keyword is optional. Delete from dental services. It's also optional in the case of the insert query. You don't have to include from, but you should be very careful about not leaving off the where. In this case, we are deleting all records where the amount of the sales is greater than or equal to 100. So, deleting all rows. I've already kind of said that much. Okay, so, update now. Update. You may update a single row or multiple rows all at the same time. If you do not, so the same rules about where apply to update. You may not initially think so, but update is exactly as dangerous as delete is, right? A couple of people are nodding. Why?
If you change one data for a specific guy, it changes for the whole tree.
Mm-hmm.
Like, if you want to change a UDAs for one guy, the whole data for all people in the data will change.
Mm-hmm. And you're still losing all of that data that's being overwritten, right? So there's, strictly speaking, not too much difference between overwriting values and just deleting them entirely. In both cases, the original data is, in some cases, irrecoverably lost. So, delete operations and update operations must be performed with the utmost care, which is probably why junior developers such as all of you are kept in select queries where you can't do any damage, right? So, here's your syntax. Update, table name, should be used to that by now. Set value, key equals value, comma delimited list. Or sorry, comma separated list. In this case, we have no where clause, so this would apply this globally to all column 1 and column 2 values. No where clause. In this case, where clause uses a primary key to locate one record, and new values are hard-coded. So, in this particular one, this is back to our community hospital database. In departments, we are setting the manager name to Bob blah blah, ha ha ha. guys. Blah, blah, blah. Where department ID is equal to 5. So, man, Brian tricked me into saying blah, blah, blah in class. Blah, 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 blah. It kind of feels like that today, though. A little bit of meta humor for you. So basically, we pick out the department, the particular department entry, according to its primary key, set a new manager for it. This is good. If you're going to be updating things, you should be doing a precision strike into the database, as few rows as possible. You should know precisely what you're doing. In this case, we have a table of items. We are updating item cost to be item cost times 1.1. In more recent times, you might say item cost is equal to item cost times 1.3 or 4. The joke is that this simulates the effect of inflation, where primary vendor ID is equal to 5. So again, we are being specific and targeting a specific thing, but in the assignment statement, we are permitted to reuse the value from the table. So we can, this bit gets a bit more programmy in the regular sense of it, right? This essentially boils down to a times equal operation in, your own favorite programming language, because it's not, it wouldn't qualify, it wouldn't qualify as being a candidate for being a favorite programming language unless it has the times equal operation. So, question?
So, if you go back to the slide here, so if you use where operator, like let's say item cost is greater than 5, so will it again go back and then see if it's 5 greater than 5 and then multiply it and then go back?
Can I stick myself in a loop that way? It's basically the question, right? I do not believe so. So, one thing that you have to kind of detach from your thinking is order in the statement is order of execution, right? The filtering will be done first. All of the entries matching this filter will be pulled, and this applied. This will be calculated as it's going through the post-filtered portion of the table. Make sense? Cool. Very good. So, subqueries. We can throw subqueries in here as well. In this case, we are taking the sum of quantity times unit cost from purchase orders, where we are looking particularly at purchase order ID number 10, and applying that as the total amount to the same purchase order, order 10, within the purchase orders table. So, in effect, right, it's kind of funny. This is kind of like, you can consider this the equivalent of like an Excel cell formula, right? It's like I've referenced two other cells in the same row. I've performed a mathematical operation and I'm binding that to another one of the columns, right? So it's, in Excel what you'd do is you'd say, in the total amount column, you'd go equals quantity times, or cell number for quantity times cell number for unit cost, right? Does that make sense? Except, of course, in the case of Excel, it's like recalculated anytime the data changes. This would only be calculated when this query is run. Make sense? Very good. So, up to now, we have been executing one SQL query at a time, but it is frequently useful to execute more than one at a time, as you might imagine. When many SQL statements are being executed, they must be terminated with a semicolon. Semicolon. In this case, we create an SQL script. These are text files, character encoded text files, typically with the .sql extension. When a batch of statements has been executed, the end of the batch can be signified by a go statement. The go statement is usually optional, but can be required under certain circumstances. Some types of create statements require that they are the first statement in a batch. So sometimes that separator is required, sometimes it's not. If you take a look up here, you've also got, use statements as well, which tell us what database we are operating on, right? Sets which database in a case where there are multiple databases, within the server, which is often the case. Yes. So. When we're in lab tomorrow, we'll worry about opening and executing files, but I would hazard a guess that probably most of you are competent to open and execute a file without direct instruction. We'll do it anyway. So, yes. So back to update. There are a variety of set commands that change the current session handling of specific information. We can set no count on. So this is different from the set that we saw in the update function. These are like global commands inside of an SQL script that set various options in the database management system. These will be hyper-specific to Microsoft SQL Server, right? Suppressing certain types of messages in the console, no count on. Setting date format to year, month, day, another thing that you can do within the file itself. When we talk about collecting up multiple scripts, it becomes useful to talk about comments. This one is in 7 minutes, right? Okay. Everybody's counting the seconds? So, comments, single line comments, double dash, multi-line comments are in Java/C style. This is actually a pretty good read. He said non-ironically. I actually didn't. So, if you want to learn about coding style, this is a great thing to skim through at some point. Not just coding style for SQL, but kind of in general, right? It's just a bunch of how-tos, Reserved words, always use uppercase. Makes them stand out. As you'll notice, the SQL is quite nicely formatted just from the simple fact that the keyword, right? There's always a single space between the keyword and the name, right? They've spaced over so that lines up. Makes it very easy to read and understand, right? This guy also recommends use of snake case because camel case is slightly more difficult to read. Everybody has their own preference, but I can see it. Snake case is generally preferred in SQL circles. Kind of depends on where you are, Okay, should probably explain what snake case is. You guys know what snake case is?
No.
The underscore?
It's with underscores, yeah. Doop. Case styles. Camel case. If you have several words, each one except the first is capitalized. Kebab case has the hyphen in between. I'm not sure I've ever seen it used in JavaScript, to be honest with you. I'm not sure I've ever seen it used in HTML, to be honest. I think the only place I've ever seen that is it like CSS selector names, you know? So I just write that CSS right there.
I think it's used in Bootstrap if you're using that.
Yeah, but Bootstrap's a CSS library,
Yeah.
so maybe this only survives to the present day in CSS. Pascal case is generally used for class names. If it's capitalized, it should be a class. Snake case, SQL. Use whatever you find most comfortable. This is by no means, these are by no means hard rules. And yes, the guidelines only, not rules, and there they are again. The same thing stated in the table. Hooray! So, any questions? Okay, yes? Oh, you did, okay. Any questions? All right, tomorrow, lab, and, yeah. Thank you and good evening.
Thank you.